Okay, hello. You know what? I was thinking for part 6 of the Elka Concorde Restoration series, I was gonna have a go at the pedal, which is very crusty indeed. Definitely has seen better days, as you can see. Yeah, that looks quite... Ooh. I'm going to start with a cleanup, I think. I think that would be a good idea. I'm gonna take it apart, clean up the insides as well. Wow, there's even wood in there. I need to wear some gloves, because I don't want to destroy my hands again, like last time. I'm going to need to take it apart, because yeah, I need to get in there. Okay, some screws have been loosened on the sides here, 4 screws. And then you pop it off. There you go. Oh god. What the fuck is that? Insect guts, that's what that is. Right, now I did grab a vacuum cleaner. It's the first thing I'm going to do. So I don't know if you can see this. Yeah, here. This is so that's dirty PCB, clean PCB. Oh, this is actually supposed to be white. Wow. Damn. So this used to be black. And now it's white. I still have some alcohol. So time to use that. First I'm gonna get all the loose crap out there. Am I gonna be able to remove this? Yes, I can. Okay, so this is nothing really special. So this is just a PCB with some tinned copper tracer that needs retinning. And it's just, yeah, they just tied a cable with the wires on there. So I'm gonna need to clean this up because this looks really dirty. Pretty close to corroding, so yeah. And there's the connector here that needs to be cleaned up. I can actually see where the PCB was over the metal here. There you go, now you can see it. So the PCB was over the metal here, and that's actually clean. The rest is rusty. It's kind of funny. Okay, so cable. I think I'm gonna zoom in. We have this connector here that needs cleaning up. And then we have this PCB that needs cleaning up. I'm gonna start with that. It's an interesting construction. There's actually a bolt here and a bolt here. I actually have to go in here with pliers, and why it isn't a normal screw, I have no idea. Okay. There we go. So that's a connector. So yeah, it's kind of like a modular construction. It's kind of interesting. Okay, and this needs to be cleaned up. Yeah, it's I don't even know what this is, but that's some crap. Okay, that was a lot of effort, but I got this stacked again. Okay, well, that's the PCB retinned and cleaned up. and the connector cleaned up, which was quite the nightmare job. So that's this thing done. So that's that. So I'm gonna put this aside. I'm gonna work on this. Yeah, the glue is dying. Oh yeah, that's just that's very rusty. Okay, so this is gonna be put aside. That needs to be cleaned up. This is gonna need to be sanded, and I think I might, I don't know, maybe put a little protection layer over it, paint, because damn, I don't think I should even touch this, to be honest. Like how this is black and brown, the two primary colors of this scent. Okay, so this is a PTFE spray for cleaning up rusty bike chains. Sometimes it works for this too. Just don't get it in electronics. Oh my god. Look at that. So I just wiped my finger over this rusty bit. I'm gonna clean it off first. Okay, so now what I'm going to do is put my screwdriver in here and give it a good big ol' whackaroo. And hopefully that will make it loose. And there it goes. There we go. So some lubricant, some percussive maintenance, and you got yourself one big old bolt. Oh my god. Look at this. So this is rust that fell off from me hammering it. That's just how bad it is. It's just flying off. Right, so I gotta be a little careful that I don't get that rust everywhere. You know what I could do? I could loosen these screws on the back here. So these 4 screws. Let's see if okay, that's good quite easily. That's these screws. Like how they put wood in here. I think it's for the weight, maybe? Just an extra little bit of weight. Ah, yeah, there it goes. Okay. Alright, it's still attached to the cable. Ah, there we go. Christ. Yeah, see, there's a big old really big axle in here. You can just about see it now, that silver thing. So that's why it wasn't coming off. This is actually built like a tank, can I just say? This thing could survive World War III, I swear. Okay, so I removed this connector over here, but it's still connected with a few wires to this frame here, which is ground wire. And then it's connected to this sort of variable resistor construction here, which is going to be very interesting. So we're going to need to unscrew this here. Yay, there we go. I got this off. And this screw wasn't even doing anything. And this screw is also new, so I don't think this is original. Okay, so we have a whole bunch of resistors. And basically what this is just a big a resistor divider of sorts. Like one connection goes here, and it's here. Connects to the first resistor here, which are then all in series. Each of these individual resistors is connected to one of these springs here. And these springs, when pressed, touch a bus bar which is connected to the output. So say if I press down on this spring at the end here, then the signal goes in here through all these resistors, through the spring, through the bus bar and out. Now if I were to press all these springs like this, say half of these, then signal comes in, goes through about half of the resistors, through this spring and to the output. This rubber piece presses these springs down as you press on the pedal, like this. So press down and up. So that's that. It should pop right off. There we go. Okay, finally got it. So the variable resistor assembly, the super rusty pedal which I need to take apart, and the frame it's all mounted on, and this is just a big chunk of plastic. A very big chunk of plastic. Because I just want to clean this. This is just plastic, so doesn't really need any special treatment, just a good scrub. And there's also this paint I need to get off there. This stuff. I need to see about that. Okay, I'm gonna wash this. While cleaning this thing, I realized, of course, there's wood bits in there, which obviously got wet. This was a bit of a dum-dum for me. So I tried to remove them. This one came out a little too easy. Yeah, this was already cracked, so of course it's fully broke off now when I pulled this out. And I still gotta do this one a little bit more carefully. But yeah, I wanna let this dry. I want to sand it and lacquer it. So I'll give it a little bit of varnish actually. Just clean it up. I'm not even sure what all that is. I think it's glue, but it looks kind of gross. So, because, if you spill something and it gets on this thing and in this wood, it's just gonna be gross. And it's kind of gross already, to be honest. So I think it would be good to remove this wood and to treat it. And yeah, I'm gonna need to glue this back together. That's a bit of a pity that's broken. But this thing has I've seen a lot of abuse. There's a crack here. You can't really see it because of the spilled paint on it, but there's a crack right across this entire bit here. And this looks kind of molten. I'm not sure what happened here, but see, this is all molten. There's like a melting mark here. There is, I believe there was another one around here somewhere, or maybe on this. Like, there's all sorts of bits and bobs that are just molten or cracked on this. So, yeah. It's really thick plastic. But yeah, it's definitely seen some abuse, this pedal. Got it. There we go. Can I remove this rubber? That's the question. Now this switch is very stuck. So So I'm gonna grab the big boy. This is this is quite a doozy. Yeah, this is not doing anything like it is now. I'm not sure if I can show this. This is what is pushed. But this is not an electrical contact, this is just something mechanical. This little bit in the middle here, between these two prongs, that's the actual switch. So, and there's like a little connecty bit here on these two things, I think those were supposed to be connected. So this is definitely broken and needs to be fixed somehow. I think I might 3D print something. In the meantime, I have been sanding and spray lacquering these pieces of wood. As you see, they look a lot better now. A little bit rough, to be honest. I need to do this side still. You can see the difference. But yeah, maybe I'll do some in-between sanding. Do some more layers. But yeah, that should take care of the wood. Okay, well, that's the first parts cleaned up. It's all the plastic stuff. And this rubber. Now nice and clean. Inside this still has a little bit of the, what you call it, the glue. It's really hard to remove, especially from rubber, but that's okay. As long as the outside looks good, and it does. And yeah, I've cleaned up all this metal. So this axle is as clean as a whistle. So that's all good, and it's all ready to be mounted again. Just waiting on the rust remover now, so I can have all the screws. And of course, this has been cleaned up. This socket now has the clamps on there that I 3D printed, so that stays in one piece, doesn't break. This bus bar has been cleaned up, as you can see. These springs have been cleaned up as much as I could, anyways. And yeah, this is just all has been cleaned. So, and the connector is all good, and the little PCB that it connects to is all good. So yeah, okay. And here are the screws and metal parts after the chemical derusting. You can see they look basically brand new now. So I'm very satisfied with this result. It's very good. I'm just gonna leave these to dry overnight. Okay, so here's the plan. I'm gonna put a dry coat of rust remover on there. For large objects that can be submerged, you can just do that according to the bottle. So I also got a little paintbrush, so I can get in the nooks and crannies. You know, I think I'm taking over the house again because I'm doing this in the kitchen. So it's now my office, the kitchen and the attic. You know, aside from the two metal pieces that are currently de-rusting, I have everything, so I figured I could mount some things. These, I think they're slightly smaller, just a tad. The metal pieces, so I'm just going to put this aside. Start with this one. This is the electronics. So this mounts in like a little slot here, PCB, and then two screws. That seems so good. Okay. I completely forgot about this. This middle bit here is connected to this one by default, I think, and when you push the button it goes like this. So you push this and then pushes this. So I need to make a little bridge between these two. Okay, so here we have the pedal volume, which is those that row of resistors with all the spring contacts and the bus bar. So I found that. The question is, where are the switches? I don't even know what the switches do actually. Maybe I need to find a manual. Okay, on the same page as the swell pedal diagram, there's also the pinout of the swell pedal connector. And I was correct in soldering that ground wire, because that indeed needed to be connected. So we have P2 and P1, which corresponds to P2 and P1 of the swell pedal. So that's, you know, pedal 1, pedal 2. We have minus 12 volts, we have A4, don't know what that is, we have PK, don't know what that is, and RMB, don't know what that is, but at least I have some names now. So I think I'm gonna have to look for these connections. It would make sense if they were connected to the rhythm unit and the backing track stuff. You know, the accompaniment. That's a word. So if I find that, these connections might give me a clue as to what is going on. Okay, so I found the brake switch, and as you can see it connects to this ROM here. So let me explain how this actually works. So this is the accompaniment. There's a few main sections. There is a counter here, which counts from 0 to 15 and then back again, so it loops around. There is A, B, C and D, which are 4 inputs from the front panel switches, which select which backing style you want. For example, tango, bossa nova, jazz, rock, and all those things. Now finally we have a bunch of outputs here. Here, these outputs are for the rhythm, for the analog drums, and these outputs are for the bass, so the bass melody. Now, your attention is drawn to these two central chips. These are ROMs, just plain old proms, I believe. And these have been pre-programmed with rhythms and melodies. Now, the way this works is deceptively simple. It looks very complex, but it's actually very, very simple. let's take a look at the address lines of the rhythms ROM. So we have the lower 4 bits of address, which come from the counter. So again, the counter counts from 0 to 15, which is 16 steps, and then back again, and it loops, constantly loops. So that's the lower 4 address bits, again 0 to 15. Now the uppermost, and I'm going to skip A4 here, the uppermost 4 bits come from these switches A, B, C and D. And these upper 4 bits select the style. So in this case, select which kind of rhythm you want. Now, again, I'm going to ignore A4 for now, because that's something special. Now, what happens is, when you press play on the accompaniment, the counter starts counting and starts going through these lower 4 bits of address. Which means that whatever is on those 16 addresses in this ROM will be output on the data bus here. So this is just 8 bits. Now in the case of the drums, it works very simply. These just go directly to the analog drums, like no filtering or whatever, because they just literally use the output bits of the ROM as gates to trigger the sounds of the analog drums. So what happens when you change the style is these upper address lines are changed. So a different section of memory inside the ROM is then addressed, because the full address that is used by the ROM is a combination of the counter and the switches. Now you're probably wondering, then what is A4 doing? Well, let's trace it. Hey, it's our brake pedal. So interestingly, and that's why it's called A4, what they did is they just literally made this an address line, this switch. So when you press the switch, this address line gets pulled high, which means that address bit A4 is now high, which again changes the address. So these 5 bits, A4 to A9, A4 to A8, are the full address of the section of memory of the 16 steps that you want to read out for the rhythm. And the break simply is the lowest bit in that address, so it switches to the next 16 bytes, 16 steps, which contain the break pattern. Now the bass melody ROM works the same way. Again, we have a counter, again we have the switches A, B, C and D, which creates an address of which the contents are then output on the 8 bits here. Now, in this case, these 8 bits are the actual note that needs to be selected. I'm not sure if all of them are for the note. I mean, the bass line doesn't have 256 notes. That's a bit ridiculous. I mean, you don't even have 256 notes on a piano. That's 88, so... So I'm not sure if all 8 bits are used purely for the note selection. It might be that some of these bits are used for maybe selecting a sound or some other things. A4 on the bass ROM actually goes to this IC here, which is then connected to some switching signals and... Oh, that might be it. There's 2 variations of bass lines you can select for each style, like a walking bass or a normal bass. So I think that's what this is for, is actually selecting the type of bass line you want. Perhaps for the walking bass they need or something, they needed this to switch more or something. I'm not entirely sure, but my somewhat educated guess is that this circuitry switches between the normal bass and the walking bass style for whatever musical style you have selected. So yeah, that's how the accompaniment section works at its core. Okay, I found R&B, which is again connected to a brake. This is a brake switch, and the other one is a, excuse the scrolling, a make switch. So I know what our switch is now. Because when you press the brake button with your foot, this is released. See, on, this is released, and the other one, this one, makes a connection. And this one then connects to ground and the other lets go of ground. So that makes sense for our switch, yeah. Okay. I didn't have black anymore, but I did have grey still, so this will do. So this is the pedal itself, which goes in here. Oh, I repaired the switch using some hot slot. I don't know if you can see this, but it should be working now. There. Just notice that the 3D printed parts here are also the same color gray as the paint. It's going to be really annoying, this. Some glue and this. I think I'll do one side first. I think I'll do this side first. I have to be quick. This needs to go in here. With this squeezed in there, which is interesting. Something heavy. Yeah, I think it's a little bit too loose. Yeah, I'll have to think about that. Let's see. That's not gonna stay. Damn. Tighten these bolts. This is such a horrible design. You can't adjust or remove this without removing this, removing this is really hard. It's not a very good design in terms of serviceability. Okay, now I need to figure out how all this fits together. Yes, this cable kind of bends over like this. The variable resistor goes here like this. So this part, this, it's in there. Let's see if it fits. This. Yay, I put it together. Except I forgot this. So now I need to take it apart again. It's a bit off here. There we go. Let's put it on this. Okay, I need a cable. In there, please. There you go. So the 3D printed clip is holding that nicely in place. So I had to remove the other side because I forgot those. I forgot to make a print and mirror. So yeah, that didn't fit. But that's okay because the other side of the connector is in perfect condition. So okay, so before I'm actually going to close it all up, I'm going to use the multimeter to test the variable resistor and test these switches, just in case. Oh, there we go. That's working perfectly fine. So I've measured the switches. This switch is working one way, but on the idle, so to say, it doesn't seem to connect properly. So the contact isn't very good. But this contact, when you actually activate the switch, works perfectly. This switch works perfectly, and of course the pedal works perfectly too. So just a minor thing in here. So I'm gonna need a flashlight. Yep. Okay, so that's working now. Yay! So aside from this this leg being broken, that's I need to fix that, but that's no biggie. Other than that, it has been fixed and cleaned up and painted, and yeah, this pedal is good to go for another 50 years. So yeah, I think that's about it for this restoration. I'm not gonna film fixing this, 'cause it's not interesting. Yeah, and one extra screw because I couldn't fit it, but that's okay. Other than that, yeah. So that concludes part 6 of the Elka Restoration Project. Next part, part 7, I'm gonna go back to the actual synthesizer stuff, fixing all those, getting more sounds out of the Elka. Yay! Okay, hope you enjoyed this, and I'll see you next video. Bye bye.